Now I'd like to call up Bill Tepfenhart of Monmouth University to moderate this panel, along with our panelists. Trained as a physicist, his areas of expertise include object-oriented software development, artificial intelligence, and software engineering. But most interestingly, he has confided to me that his beard is old enough to buy liquor. That is an accomplishment. Take that, ZZ Top band members and Duck Dynasty posers. Anyway, I'm glad you could join us today, Bill. Take it away.
All right, we have our 4 panelists here. Basically, let me introduce them. Karen Roberts, I'm sorry, Wendy Roberts. Ben Gwen, okay, out of order. Costas Bekris and Brendan Englot. So basically the topic of this is about what's next in robot technology. So we're going to introduce ourselves basically a little bit with respect to that topic. So Wendy, please.
Thank you.
I think it's on.
Is it on? Oh, okay. So hello everyone. I'm Wendy Roberts, and even though my sign says Future Skies, that's actually true. I am the owner of Future Skies, but also I think the reason I'm here today is for 5 Elements Robotics. So we are the makers of Budgie. I don't know if you've seen him over here in the corner. He's the friendly-looking robot with 2 different size eyes who follows you around and carries your things. A very awesome concept. So if you get a chance, please stop by and visit us. This robot is currently for sale to the consumer market, and we look forward to hearing from you and seeing you. Thanks.
My name is Bing Guan. I'm the CTO at Videotek. So Videotek is a visual communication collaboration company, and you may be wondering why I'm here at the robot show, right? So we're looking, have partnered with the manufacturer to have the robot in the telepresence and also the other applications, right? Like a telemedicine or telehealth applications and the others. So we focus on more enterprise environment. So our application more focus on the enterprise or large enterprise environment and even government, how they're using a robot for the different applications. So looking forward to collaborate with the folks here.
Hello everyone, my name is Kostas Bekris. I'm an assistant professor at the Computer Science Department at Rutgers University. I work in the area of motion and manipulation planning. The problem is to design the software that will allow robots to perform tasks efficiently and safely, especially in the presence of people. And we work with cool robots like the one that we are exhibiting here on your right. It's the blue and white robot that is currently moving. And this is a very exciting type of robot. It's human-like, it's humanoid, and it is able to use in applications that vary from the industry in manufacturing, but also it's the same type of problems that you could have in the case of service robots, like a personal assistant. And I'm looking forward to telling you more about the kind of technology that we're developing here at Rutgers.
Hi, I'm Brendan Englot. I'm an assistant professor in the Mechanical Engineering Department at Stevens Institute of Technology. And I first began working with robots during my graduate studies. At MIT, we were trying to develop an underwater robot that could perform a fully autonomous in-water ship hull inspection for the Navy. At the current time, a few years later, the robot's now commercially a commercial product in use inspecting ships in the defense sector. And more recently than that, I was working in aerial drones with United Technologies, thinking specifically about unmanned helicopters. Now at Stevens, we're also going back to research with underwater systems, and we have our Videotek remotely operated vehicle here on display, and I'll be able to tell you more about autonomous navigation capabilities that we're developing for that vehicle.
All right. I really want to just open up the questions to our panelists about what's next in the robot technology, basically addressing the question from their individual interests and things.
So what's next? What's next with the robot technology? I think what I'd like to address first is this age-old question. How many of you have heard robots are taking our jobs? Right? How many of you believe robots are taking our jobs? Yes, robots are going to take our jobs. But you know what? That's a good thing. There are a lot of jobs we probably don't want to do. Having those robots take those jobs for us, particularly things like taking one piece and moving it over here, right? How mind-numbing is that? Having a robot that can do these kinds of things, go into buildings where there are explosive devices. Do you want to get blown up? So the point is, I think, about robots taking our jobs is that I believe for us it's going to help us to evolve as a race, as a species. Instead of doing these mind-numbing tasks, instead of doing tasks that are quite dangerous, what we'll be able to do instead is to evolve our minds, to use our skills, and to be able to be something more than we are today. Thank you.
So I think it's great, from Wendy's comment. So one of the things in our mind facing the enterprise environment is robot is fantastic. Like the robot on the left side, that's the iRobot with full autonomous mapping capability, and you can let him to virtual travel, virtual tour everywhere. But the situation right now on this one is too costly, right? How can we reduce the cost? In other words, we can put in a lot of different technologies on the robot, but towards the end of the day, it's affordable, right? Not only for the home, but also for the business, the same challenge. How can we reduce the cost of the robot and for affordable to a lot of, enterprise customers, and then they can use this more often, they can buy more, the robot is there. So I think to me is reduce the cost and more affordable is a biggest challenge, and hopefully we can, have some solutions down the road.
I'm specifically interested in the changes that are going to happen in manufacturing and automation. Remember, a few decades ago, there was the automation of the manufacturing of vehicles. There used to be the joke, do not buy a car that was manufactured on a Friday because probably the quality was lower because the workers were tired. And it was around that period that Japanese manufacturers actually got a huge lead versus the American manufacturers. Since then, of course, the automations of vehicles across the industry has taken place. But robotics has helped so far only these big manufacturers. What about small manufacturing facilities? In these cases, we do not have such a structured setup. So what's next there is that we can have robotics technology that can adapt to a manufacturing floor that is actually flexible. New products come, new orders come. Perhaps you order something that is very specific to your needs online, and then a robot is able to design it and build it for you, and it is shipped to you via robots.
So I definitely agree with those sentiments, and I think about that also more in the context of autonomous vehicles navigating outdoors in harsh environments, areas right now where there's very little autonomy and very little automation. Underwater is an area we've identified as one of the most compelling for innovation because human intervention is pervasive everywhere. Even the robots that are currently in use in the oil and gas industry in deep water off oil platforms are very, very heavily teleoperated by humans that instruct them on every single task that they do. And I think you're going to see some real game-changing evolution in the level of autonomy that can reach out into unstructured environments to work in industries like that, for disaster relief, for monitoring of the environment, areas where you don't see robots today. I think the level of autonomy and automation is going to increase.
I'd like to kind of bring into play as to who's doing the next generation of robots. And there's a large maker movement in this country where people are basically building things themselves, sharing designs, open source software for the control of robots, drones, etc. And I'd like to know what you think of this movement and where it may take us versus pushing the boundaries from a research lab perspective.
So actually, until the 80s, United States was leading robotics manufacturing, and I'm referring more to the big industrial robots. And then actually a lot of this manufacturing left the United States and today is dominated by Japanese companies and European companies. Until very recently, there was a company in Massachusetts from the creator of iRobot that I think it may bring a change in how things are taking place. Rethink Robotics is building a new type of robot that is actually friendly to be right next to work right next to people. So their robot called Baxter, which we also have at Rutgers University, is 100% built here in the United States, and it is closer to this ideal of the makers movement as well, that might allow perhaps someone to use as well a robot in order to design new tools.
So yeah, the barrier to entry for getting involved in robotics is dropping and dropping in terms of cost, in terms of the amount of experience you need to have developing software and integrating hardware. There are many more open robot platforms now that you can buy off the shelf and get working very quickly, taking advantage of open software as well. But in my field in particular, underwater robotics, the barrier to entry is so high in terms of cost. If we want any situational awareness underwater, you need to spend tens of thousands of dollars for the sensors that are required to do that. We would love to see that price point drop so that hobbyists as well could get involved and contribute to robotics in the way they've done in other fields. You're starting to see that with the maker movement. In fact, now there's a product called the Open ROV that you can buy the plans for and build yourself for about $800, I think, which is immensely low cost compared to the other platforms out there. And I'm very hopeful that that'll increase in the future, and there'll be more and more maker-induced robots that really are game-changing, disruptive technologies that lower the cost and the barrier to entry.
So talking about lower the cost, what's the other options or potential options we can lower the cost? Because I think that's kind of a key challenge right now for a lot of people, not only for the consumer, but also business as well, right? Any ideas or any thoughts?
Well, just observing maybe what has happened in the last 10 years or so, and you could probably comment on this. One thing that has really been disruptive in robotics is the Xbox Kinect sensor, which was built to be used with a video game system. It would detect your profile for the purpose of playing video games. And hobbyists and roboticists took that, turned it around, stuck it on robots, and began using it as a perceptual sensor. And it's been completely game-changing. And it's on Professor Beckeris' robot and maybe some others that you'll see here today. Disruptive technologies that change robotics might come from anywhere, from unexpected places, because robots really are integrated systems. So where the next will come from, I don't know, but I'm sure there'll be more coming in the future.
Yeah, so always the cost in robotics, I think, relates to three aspects. Sensing, and you were very correct in mentioning the Kinect sensor, which has really helped. The other one is the actuation themselves, so the actual mechanical parts, where there has also been great progress. And the third, as a computer scientist, is computation. And one way that we can make more powerful robots, but perhaps not increasing the cost, is by outsourcing a lot of the computation as well on the cloud. So perhaps a robot does not really perform all the computations locally, but can talk to a computing cloud, a large server, where much more information is available, much more storage. Perhaps you can share information from multiple robots in order to solve a problem. If one robot has seen a certain scene and has solved a problem there, this knowledge can be uploaded to the cloud, and then it can be shared with another robot that faces the same challenge.
That's a good comment. iRobot we have there right now is access to the internet access in the cloud, which right now doesn't work because the Wi-Fi is not working here. But all the maps and the mapping information, all the stuff is sitting in the cloud, and you can configure everything and control everything in the cloud. So then this robot is one button to push. When you push button to say go there, the robot is going to route the shortest path to go there, and by its own, you don't need to do anything in the middle. There's no interruption of human beings.
I would like to point out that there's a 3D printer coming out that's based on very old industrial robotic technologies that used to sell for $50,000 plus. it's coming out at around $200. So when you see a drop in price like that, it's kind of obvious that it's now at a price that can move into the household that wasn't possible in the past. Do you see any legal or social barriers to a wider spread adoption of robots and robot technology?
Okay, I actually haven't seen any. In terms of legal barriers, I haven't seen any. It seems like Europe, in terms of the standards, right, for what to build a robot to, in terms of how it can interface to the United States, interface with other people, Europe has some pretty good standards out there. And when we built our budgie, we used those standards to build to because there weren't any for the U.S. But in terms of actual, rules, I think that the technologies are there now only recently, maybe like in the last year or two, where you can actually make a robot that can go into a person's home and can really safely, right, with collision avoidance, with cliff sensors, be able to safely interact with people. If you we just roll back the clock like maybe 2-3 years, in the factories, right, all the robots had fences around them, right, because they couldn't get anywhere near people. The ability to sense what was around it just wasn't there. So today, we've really come a long way to be able to kind of put those robots out there, put them in the homes, have people walking around with them on city streets, and robots are coming. So.
Yeah, I want to comment that there were some very strict rules about how you would place your robot in a factory floor, ISO protocols, and how they would be separated from people. But the development of technology that is human-friendly now is allowing to have workers operating right next to robots. And this is also affecting our research because now I don't have to be afraid that the student will have an accident when they're working with a robot in the lab because we have this compliant mechanism. So when the robot hits something, it immediately realizes that it has hit a surface and it stops moving. And that's again the progress in technology that helps us to go there.
As a researcher that does outdoor robotics, I guess I am always continually thinking about the regulatory process of designing and certifying a safe experiment, doing that a little bit in industry, in the aerospace sector, and now doing it with underwater systems. You always need to think carefully about where the robot's going to be in the environment. And I guess that causes me to reflect just on the fact that unlike maybe other movements where technologies have evolved quickly, robots can do damage. They're heavy masses, they can be fast-moving inertias, and they're becoming more and more pervasive. So I do think about the safety implications of that. And I get a little nervous that the movement and the growth of the movement will fluctuate as more and more of these heavy masses and fast-moving systems get into the hands of hobbyists. As I watch more and more YouTube videos of drones flying in places where they're not supposed to fly, filming the New York skyline, I worry a little about the implications for the movement moving forward and for researchers being able to do those experiments. But I do think of safety generally doing outdoor robots.
And an area of research that's becoming increasingly active is human-robot interaction, where you need the expertise, of the mechanical engineers, of the computer scientists, but also now of psychologists that are going to help us understand what is the best way to interact with this new technology. So we're collaborating, for example, at Rutgers. There's a collaboration between the psychology department and computer science exactly in this area, which is emerging.
All right. We had discussed earlier about possibly asking each other questions about what you're interested in that the others are working on. So,
well, how difficult is it to start a new company in robotics today?
Very difficult. Yeah, it's interesting. I've had a couple of people come up to me while we've been here. When we started 5 Elements Robotics, luckily, I had started Future Skies, which is on my sign here, back in 2001. And at that time, Future Skies, we did software for the military and biometric software. And so for 12 years, it was a very successful company. And because of that, I had the funding, right, to start my own robotics company. But what I found was that if you want to get backing for a startup, right, it's very, very difficult. If you want to get a bank to give you a loan, kind of forget it, right? And then also, how do you recruit really good talent? So I think for myself, I was in a very unique position that my other company had a lot of really incredibly talented geniuses who were really excited when I said we're going to make a robot. They were all jumping up and down volunteering, so it was really awesome for me. But yeah, I think it's very, very hard to start a company, but more so, how do you get something from the R&D lab into the hands of the consumer? Because I feel that when I started my company, and I think even now, what we see so much of is, we see all these really cool things on the news, right? Do we see new cool robotic stuff on the news all the time? But can you buy it? No, right? You can't buy it. And so I think a really important goal for any kind of a startup is not to just let me get a cool technology, but let me get a cool technology that's going to solve a real world problem at an affordable price that I can get into people's hands quickly, right? Because they don't want to wait 10 years for it.
So I guess, talking about your affordable and then technology moving into consumers, how do you get your customers? In other words, how do you find your customers and then find people who really can afford your robot and then moving forward?
Oh, how can I? Okay. Yeah, we've actually we've been very blessed in that for our particular robot, it turns out that because it's kind of one of a kind at this point, a lot of the news channels have been picking it up. So we've had like Fox News. We've been on Fox News about 5 times. And that was free advertising. So yeah, we found a lot of customers that way. And then it turns out that I'm trying to think of a good way to put this, but it turns out that most of the Asian countries and even European countries seem to have a much bigger love affair with robots, particularly ones that the consumers can go out and buy, than the United States. So what I find is we get ourselves shown on the air on TV in all these other countries all the time. So many of our orders, I would say a good 75% of our pre-orders have come from countries outside of the US. Does that answer the question?
Yeah.
I have a comment, but then also a question for you guys. The comment is I do agree with what you're saying about the fact that the current state of the art in robotics is often oversold through demos where a system has been very carefully prepared and rehearsed to do one task, and it's filmed doing that task, and it looks like something groundbreaking has been performed. And we're always a little hesitant about that because the public might think the state of robotics is in a more advanced place than it really is. And so, if you were to look at the latest research-related competition that happened, the DARPA Robotics Challenge, you'd see how difficult a time robots have doing tasks in real-world environments that are unstructured. The question I was going to ask you guys is, I was interested by your comment that robots will displace current jobs. I agree with that to some extent myself. I was wondering what you think the economy of the future will look like if certain robots displace jobs, for example, helping out in the home, providing assistive care, performing certain tasks in manufacturing. What will the economy of the future look like from your perspective?
That is actually a question I feel very passionate about because I feel when I first started to make a robotic company and to put robots out there, I thought, wow, what's going to happen, right, to people in their jobs? Am I actually doing a disservice? And I read an article in CNN one day that really opened up my eyes. What it said was, as robots come, what has to come too is this social change, right? And we can think about it going back throughout our history, even as a country. We've seen many technologies that have created a huge social change. Cell phones, right? In the past, people couldn't get you, right, if you weren't home. Now, everybody can reach you no matter where you are. There's a big social change that goes along with that. And I think that for robots, the social change is going to be, we're not going to have to work 8 hours a day anymore. You're right. Who here wants to work 8 hours a day, 10 hours a day? How many people work 12 hours a day? I work 12 hours a day. You know, how much time would we like to spend with our families? Right? How many of you started out your careers thinking, you know what, my hobby's going to be, I'm going to do art, right? Or I'm going to do music. And you found you can't do any of those things because you're too busy, right, in your job, making money, right? So I think as we go into the future, that as a race, what we'll need to do is have a system set up where those that like to do tech things, that want to do different jobs can do them, but there's enough food, right? Because we've got the robots taking care of all of that. There's enough resources. All that the things that we need to live are taken care of. And instead, what we do is we do the things that make us creative, that help us evolve.
Okay, I would like to open the discussion to the questions from the audience. So if anyone has a question, raise your hand.
Is this working? Great.
So pertaining to that last comment you just had, what do you think about idiocracy, or that drones will go so far to make it so that people will get lazy and complacent, and that we would have a future, a grim future, where no one would even know how to work these drones because they would just be doing everything for us?
Well, many things were automated with the introduction of computers. So we do not use so many people that are typewriting today, and each one of us is doing that work on their own computer. It has not made us lazier, it has made us work even harder, just because we can do so many things in so many different ways, much more capable.
Hi, many of us of a certain age remember Rosie from the Jetsons, and that was the future of robots. Fast forward to 2015, we still have robots that are kind of the size of me, and they kind of move about like this speed. There are people working on robots for like construction using trapezoidal elements where the robot will work at 60 hertz. That's 60 snaps a second. Okay? On the other hand, with your application on ship inspections, there isn't a lot of need for rush. So maybe you set that robot on a mission to go for a full year to cover a ship while it's, something like that. Anyway, the point is, at both the size and the speed scale, please comment on non-human scales.
Yeah, that's very interesting. I think you're right. We don't need to limit ourselves to just thinking about robots replicating humans, doing human tasks. There are tons of limitless possibilities. There are many researchers out there trying to mimic biology. Robot insects, micro robots, flexible robots. I would say there are many interesting creative possibilities, even at the micro nano scale, and in the medical domain, robots that could literally be injected into you, that could possibly navigate through your body and take measurements and do medical diagnostics or assist in an operation. So I agree with you there. The other thing I think is really interesting that I look forward to personally is, robots being electronic systems are limited really only by the speed of light, right? So there is a point in the future where maybe they'll be able to solve tasks not just computationally, but even physically faster than we can. And perhaps we can eventually have aggressive, agile systems that can even surpass the capabilities of biological systems. I think it's possible. It's probably quite a ways off, but definitely something the research community should be thinking about.
So can I make a comment about the speed? Robots are very good at moving fast as long as they know everything about their environment. For example, in the food industry, when you see the robots that are used for packaging on conveyor belts, they're impressive. They can pick up something like 300 items per minute. And that's a speed that is unparalleled in terms of human capabilities. But this is a very structured, known environment, and every change that is happening is controlled by the robot. Now, we participated last year in the Amazon Picking Challenge, where we needed to have the manipulator pick up items from a shelf and put them inside bins. A human worker at Amazon warehouses can pick about 12 items in 90 seconds. The winning team in the competition managed to pick 10 items in 20 minutes. What's the difference there? We do not know where the items are, and we need to sense, to reason, and perform all these tasks. But we're going to get there, I believe.
2 more.
Hi, Wendy. Brandon, I got a question for you. Wendy, you said that robots would make us be able to be more creative, correct? More creative. Doesn't the robot need that creation from the human side? And you were talking about the programming. It all starts with the person, not the robot. The robot is just the end of the intelligence of the human race and the programming.
Thank you so much. That was an excellent question. I think a very important point there is that even as the robots continue to evolve, who's behind it evolving them, right? It's us, right? And so I think we'll continue to grow in intelligence, we'll continue to grow in wisdom. I think not only knowledge and smarts, but the wisdom is the really important part of all this, because we need to use our wisdom, not our knowledge, our wisdom, to know the right way to integrate the robots into our society and the right way to evolve culturally so that it's a win-win for everyone. Thank you. That's a very important point.
Yeah, and I would also say that almost everyone in the research community is principally thinking about how can we make robots work better for us? You know, how can we put them to work doing things more efficiently that will serve society in beneficial ways and make society safer, more productive, allow people to live longer lifespans, and you know, maybe even reduce the length of the work week. That's definitely the end goal, and at least for the foreseeable future, I think humans will also be a part of the process. There are some interesting, groundbreaking areas of research where people are getting into robots, building other robots, designing other robots, tasking them, but at the end of the day, there is always a human in the process for now.
Actually, one of the objectives is to make robots perform tasks without having to program them, and it's very exciting. Perhaps you can demonstrate something to a robot, and then the robot can realize what are the actions that it needs to repeat so as to solve that task.